Hello everyone. For this tutorial video, I like to explain the more simpler type of equations reducible to quadratic form, which are equations that look generally like the standard quadratic formula, but whose powers are different, or who have one slight deviation, but still look about the same as the normal quadratic equation. In particular, if we have a specific example of this, we see it might look messy or unpredictable at first, and not something we can use any of the methods we know on, but if we stop to look at this carefully, we can see that 2/3 is 2 times 1/3. So we can state that u equals x raised to the power of 1/3, because we remember from the properties of exponents, an exponent raised to another exponent is the exponents multiplied. So this means x raised to the power of 2/3 can be rewritten as u squared. And now we have it in terms of a quadratic equation, which we solve by factoring. And u equals -3 or 5. So -3 and 5 are the cube root of something, which we figure out simply by cubing them. So we have -3 cubed is -27, and 5 cubed is 125. Those are our answers for the exact value of x. If we have something like this, which does not look like an overt or obvious example, because there appears to be no exponents, we can see that we remember the square root can be rewritten as something to the power of 1/2. So we do it that way. We see in this case, u equals the square root of z. So u squared must equal z. So now we plug in u squared for z and u for the square root of z where appropriate, and we have a quadratic equation in standard form. We solve by factoring, we get u equals 2 or 7. So the square root of z equals 2 or 7. We square this to get z by itself. Z equals 4 or 49. Now that we have figured out simpler types of equations reducible to quadratic form, we can figure out more complex types in the next video, especially involving roots or radicals. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.